At the far edges of existence, where reality seems to fade into a whisper of uncertainty, a question arises, one that has haunted humanity since the dawn of consciousness. What is the mind, really? Is it merely a fleeting spark in the vast ocean of the universe, or is it the hidden force that shapes everything that exists? Imagine, for a moment, that everything you believe you know about yourself, about the world, about time and space, is only the surface of a much deeper mystery. A mystery that not only challenges science, but challenges reality itself. Today, I invite you to cross the threshold of the known and enter a territory where questions outnumber answers, where quantum physics and philosophy intertwine in a dizzying dance, and where consciousness, that inaccessible spark that allows us to ask why we exist, reveals itself as the greatest enigma of all. Can the mind influence matter? Is consciousness merely an illusion? Or is it the hidden key that sustains the fabric of the cosmos? Could it be that your very ability to observe, to think, to dream, is the force that gives meaning to everything that exists? On this journey, we will not only explore the limits of science, but also the depths of human experience. We will examine experiments that have shaken the foundations of physics, theories that brush the edge of imagination, and questions that have kept the greatest thinkers in history awake at night. But above all, I invite you to look inward, to question what you believe you know about yourself, about your mind, about the universe itself. If you have ever felt the vertigo of wondering who you truly are, if you have ever suspected that reality might be far stranger than it appears, this is your moment. Allow me to be your guide on this unique journey, where every answer opens new doors and every mystery is an invitation to go even deeper. And if explorations like this ignite your curiosity, if you feel that curiosity is the true compass of your existence, consider subscribing to the Quantum Observer. Together, we can continue unraveling the deepest secrets of the universe and the mind. Prepare yourself, because from this moment on, your view of consciousness, and perhaps of reality itself, may never be the same. Chapter 1. What is consciousness? The enigma that defies science. Imagine for a moment that you open your eyes and suddenly everything you believed you knew about yourself and the world disappears. There are no names, no memories, no words, only a silent presence remains. A kind of invisible witness that observes, feels, and experiences. Who is that witness? What is that mysterious spark within you, capable of questioning its own existence? That is consciousness, the greatest enigma of human experience, the mystery that defies science and remains unsolved to this day. 1. Why is consciousness such a profound mystery? Consciousness is, above all, the fact that there is something it is like to be you. It is subjective experience, the feeling of being here and now, of having thoughts, emotions, and perceptions. It is not merely the functioning of a biological brain, nor the sum of chemical and electrical processes. It is the intransferable quality of experience, something no one else can feel for you. You can describe the color red, but no one can see red exactly as you do. You can explain pain, but no one can feel your pain from the inside. Consciousness is something more, something that escapes any mechanical definition. Since ancient times, philosophers have attempted to capture its essence. René Descartes summarized it in his famous phrase, "I think, therefore I am," pointing out that the only absolute certainty is the existence of a conscious mind. But what exactly is that mind? Is it a substance separate from the body, as Descartes believed? Or is it simply an emergent function of matter, as many modern scientists suggest? 2. Can science explain consciousness? For centuries, consciousness belonged exclusively to the realms of philosophy and religion. But in recent decades, science has attempted to storm this mysterious fortress. Neuroscience has mapped regions of the brain, identified neural correlates of experience, and shown how certain areas activate when we feel love, fear, or joy. Yet there is a boundary science has not crossed, the boundary between brain activity and subjective experience. You can observe a brain in action, you can measure electrical impulses, you can record synaptic chemistry. But none of these measurements tell you what it is like to be that person, how the world feels from their unique perspective. This is the famous hard problem of consciousness, formulated by philosopher David Chalmers. Why do certain physical processes give rise to subjective experience? Why are we not simply biological machines with no inner world? 3. Is consciousness an illusion? Some scientists argue that consciousness is merely an illusion, a byproduct of brain complexity. According to this view, what we call the mind is nothing more than billions of neurons interacting, with nothing special occurring beyond physics and chemistry. But this explanation, elegant in its simplicity, fails to resolve the mystery. Because even if consciousness were an illusion, who is being deceived? Who experiences that illusion? 4. Is consciousness universal or uniquely human? Another question arises, is consciousness exclusive to our species, or does it exist in some form in other animals, plants, or even inert matter? Can an artificial intelligence become conscious? Does a bee feel something? An octopus? A tree? Or is consciousness a fundamental property of the universe, as basic as space and time? Some scientists and philosophers propose panpsychism, the idea that consciousness is an elemental property present in everything that exists, though in vastly different degrees. Others argue that consciousness emerges only when complexity reaches a certain threshold, as in the human brain. Yet no one has conclusively demonstrated what consciousness is, how it arises, or why it exists. 5. What role does consciousness play in reality? Perhaps the most unsettling question of all is whether consciousness is merely a passive byproduct of matter, or whether it plays an active role in shaping reality. Are you just a spectator, or are you also a creator? Can your mind influence the physical world, or is everything determined by impersonal laws? This is where quantum physics enters the stage, challenging everything we thought we knew about the relationship between the observer and the observed. But before entering that fascinating territory, one thing must be clear. For now, consciousness remains the greatest mystery in science, a mystery that challenges not only physics, but logic itself. 6. Why does this mystery matter? You may wonder why you should care about something so abstract. But consciousness is the foundation of all experience. It allows you to love, to fear, to create, to dream. It is the stage upon which your entire life unfolds. Without consciousness, there would be no science, no art, no history, no humanity. Everything you value, everything you are, depends on that mysterious spark burning within you. Exploring consciousness is not merely an intellectual exercise. It is an existential quest, an odyssey to the very heart of what it means to be human. And although science has not yet solved the enigma, every step brings us closer to a deeper understanding of ourselves and the universe. 7. Are we close to solving the enigma? Today, consciousness is the greatest challenge of modern science. Some believe we stand on the brink of a revolution, that we will soon uncover the hidden mechanisms that generate it. Others believe the mystery is so profound it may never be solved by the human mind. But one thing is certain. The more we investigate, the more we realize that consciousness is not merely a biological phenomenon. It may be the key to understanding the entire universe. In the next chapters, we will explore how quantum physics has reignited the debate about the mind, how the strangest experiments in science seem to point toward an unexpected link between observer and reality, and how the boldest theories suggest that consciousness may be the hidden force that gives meaning to everything that exists. So, if you have ever felt the urge to look beyond the obvious, if you have ever wondered who you truly are, join me on this journey, because the mystery of consciousness is, ultimately, the mystery of your own existence. Chapter 2. The Limits of Classical Physics in the Face of the Mind. 1. Can classical physics explain consciousness? Imagine for a moment that your mind is nothing more than a collection of atoms, a dance of molecules following precise laws like the gears of a cosmic clock. For centuries, classical physics envisioned such a universe, ruled by immutable laws, where every thought, every emotion, every spark of consciousness would be nothing more than the echo of particles obeying causality. But can this vision truly encompass the mystery of the mind? Can traditional physics, with all its mathematical precision, account for the subjective experience of inner life? So far, the answer is a resounding no. Despite neuroscience mapping the brain and biology dissecting its cells, the leap between physical activity and conscious experience remains an unfathomable abyss. This problem is so deep it has a name: the hard problem of consciousness. How can neuronal activity, electricity and chemistry, become thoughts, feelings, dreams? No characteristic, configuration, or activity of the physical world, as conceived by classical physics, can give rise to the conscious experience that defines our thoughts and emotions. 2. The classical paradigm. Biological machines without mystery. For decades, most biologists and physicists adopted the view that we are essentially classical machines. Thought would be nothing more than coordinated matter and motion, a coherent pattern in a multidimensional system interacting with the world. According to this paradigm, consciousness makes no difference to behavior. Everything is determined by microscopic causation, with no need to invoke the mystery of the mind. Mental states would be identical to physical brain states, or merely emergent properties like wetness arising from water molecules. But this model, elegant in its simplicity, encounters an insurmountable obstacle. It cannot explain why subjective experience exists at all. At the end of the causal chain, there is someone who feels, who observes, who dreams. Why are we not merely biological machines with no inner world? 3. Deterministic chaos and the illusion of mind. Some scientists have attempted to save the classical paradigm by appealing to deterministic chaos. According to this idea, the mind emerges from chaos in the brain. Small changes in initial conditions lead to divergent trajectories, creating the illusion of freedom and consciousness. Yet even this approach fails to cross the abyss. Chaos may explain complexity, but it does not explain subjective experience, the feeling of being me rather than just a complex machine. 4. The hard problem, the unexplainable gap. Here lies the true limit of classical physics. We can measure, record, and analyze brain activity, but nothing in those measurements explains why conscious experience arises. The process by which the brain generates thoughts and feelings remains unknown. Physical mechanisms and computation cannot explain why we have feelings, awareness, and inner life. The mystery remains intact, like a shadow resisting the light of science. 5. Reductionism and its limits. Materialist reductionism has been useful in explaining many aspects of nature, but when it confronts consciousness, it encounters a conceptual barrier. Subjective experience does not appear reducible to physical processes, no matter how finely we break them down. Consciousness slips through the fingers of scientific explanation like water through open hands. 6. The missing observer. In classical physics, the observer is irrelevant. The universe exists and evolves according to objective laws, whether or not anyone is watching. But consciousness, by its very nature, is inseparable from the observer. There is no experience without someone to experience it. This divorce between classical physics and subjective experience lies at the heart of the mystery. Science can describe the outer world, but it cannot penetrate the inner one. 7. Is consciousness an illusion? Some scientists, such as Daniel Dennett, have claimed that consciousness is merely an illusion, a byproduct of brain complexity. But even this explanation only shifts the problem. Who experiences that illusion? Who is the subject of experience? Consciousness refuses to be reduced to a mere biological function. It is the mystery that remains when everything else has been explained. 8. The causal gap and the need for a new paradigm. Classical physics cannot, on its own, generate a fully deterministic and dynamic theory of the mind. There is a causal gap, a gap between objective description and subjective experience. The numbers of classical physics describe the internal properties of a physical system, but they do not explain experience itself. To move forward in the problem of consciousness, it seems necessary to go beyond the classically conceived physical world. 9. The emergence of quantum physics. Faced with this dead end, quantum physics appears as a possible way forward. Unlike classical physics, quantum mechanics introduces something radically new: the importance of the observer. In the quantum world, reality is not fully defined until it is observed. The act of observation, the choice of what to measure, influences the outcome. This strange feature has led some physicists and philosophers to wonder whether consciousness plays a fundamental role in the very nature of reality. 10. A shift in paradigm. Classical physics, with its precision and explanatory power, has led humanity to astonishing achievements. But when it confronts the mystery of the mind, its limits become clear. Consciousness remains an unexplained abyss, an enigma that challenges both science and philosophy. Perhaps to understand it, we must look beyond classical laws and enter the strange and fascinating territories of quantum physics. In the next chapters, we will explore how quantum mechanics challenges our intuitive understanding of the world and why many scientists believe that there, at the heart of indeterminacy, may lie the key to understanding consciousness. Chapter 3. Quantum Mechanics. The realm where reality begins to blur. 1. What is quantum mechanics, and why does it defy intuition? Imagine a world where the rules governing everyday life no longer apply. A world where a particle can exist in multiple places at once, where cause and effect seem to dance in an unpredictable rhythm, and where reality only becomes defined when someone observes it. This is the universe of quantum mechanics. A realm where matter and energy behave in ways so strange that they challenge even our most basic logic. Here, the smallest objects in the cosmos, electrons, photons, quarks, are governed by laws that feel almost dreamlike. Quantum physics emerged at the beginning of the 20th century, when scientists discovered that light and matter did not behave as expected. Max Planck, Albert Einstein, Niels Bohr, and Werner Heisenberg opened a door to a universe where certainty is replaced by probability, and reality itself becomes a landscape of possibilities. 2. Wave-particle. Duality, the paradox at the heart of matter. One of the fundamental principles of quantum mechanics is wave-particle duality. Subatomic particles, such as electrons and photons, can behave both as particles, tiny points of matter, and as waves, fields of energy spreading through space. This duality is not a mathematical curiosity. It has been confirmed by countless experiments. When not observed, particles exist as a cloud of probabilities, a superposition of all possible states. But when we measure them, they collapse into a single, defined state. It is as if reality chooses one possibility the moment it is observed. 3. The uncertainty principle, the limit of knowledge. In the classical world, you can measure the position and speed of an object with as much precision as you wish. But in the quantum universe, Heisenberg's uncertainty principle tells us that this is impossible. The more precisely you know a particle's position, the less you can know about its velocity, and vice versa. This is not a limitation of technology. It is a fundamental feature of nature itself. At its deepest level, reality is indeterminate. 4. Quantum superposition, existing in many states at once. Perhaps the most unsettling aspect of quantum mechanics is superposition. A particle can exist in multiple states simultaneously, as if an electron were in two places at the same time. In Schrödinger's famous thought experiment, a cat can be both alive and dead at once. Only when someone observes the system does the superposition collapse into a single outcome. What does this mean for reality? Is the world nothing more than a collection of possibilities until we look at it? 5. Wave function. Collapse, reality as an act of observation. In quantum physics, the state of a particle is described by a wave function, a mathematical expression that contains all possible outcomes. When a measurement occurs, the wave function collapses into a single, definite state. Physicist Roger Penrose proposed that each time a quantum wave function collapses in the brain, a moment of conscious experience arises. Though controversial, this idea suggests that consciousness may be deeply connected to quantum processes. 6. Quantum entanglement. Connections beyond space and time. Quantum entanglement is another astonishing phenomenon. Two particles can become so deeply linked that the state of one instantly affects the state of the other, no matter how far apart they are. Albert Einstein called this spooky action at a distance. Entanglement challenges the classical idea of a local and separate universe and has led some to wonder whether consciousness itself could be entangled with the cosmos. 7. Coherence and decoherence, the fragile balance of the quantum world. For quantum effects to appear, particles must remain in a state of coherence, a delicate synchronization. But in the macroscopic world, interaction with the environment causes decoherence. The system loses its quantum character and begins to behave classically. One of the greatest challenges for quantum theories of consciousness is explaining how the brain, a warm, wet, and noisy organ, could maintain quantum coherence long enough to influence the mind. 8. The role of the observer. Do we create reality by observing it? Perhaps the most provocative question in quantum mechanics is whether reality exists independently of the observer. In the double-slit experiment, the mere presence of a measuring device changes the outcome of the experiment, as if the universe waits to be observed before deciding what is real. Does this mean consciousness plays an active role in shaping reality? Or is this only an illusion produced by the complexity of the quantum world? 9. Consciousness and quantum physics. An unknown bridge. In recent decades, scientists such as Roger Penrose and Stuart Hameroff have proposed that consciousness may arise from quantum processes in the brain, particularly within neuronal microtubules. These tiny structures inside brain cells may allow the mind to function like a quantum wave, existing in multiple states and perhaps connecting to a universal consciousness. Though many scientists remain skeptical, recent experiments have shown that quantum processes can occur in biological systems, opening the door to new possibilities. 10. The mystery persists. Quantum mechanics forces us to rethink everything we believed about matter, energy, and reality itself. It reveals a universe where certainty gives way to possibility, where the observer seems to play a fundamental role and where consciousness may be the key to unlocking the deepest secrets of the cosmos. In the next chapter, we will explore the double-slit experiment in the role of the observer. To discover how quantum physics challenges the boundary between mind and matter, and why this experiment has been called the gateway to the mystery. Chapter 4. The double-slit experiment and the observer. 1. The experiment that challenged reality. Imagine a silent laboratory. At its center, a screen, 2 tiny slits, and a source of particles. What is about to happen will not only change the history of physics, but also challenge everything we think we know about reality. The double-slit experiment, conceived by Thomas Young in the 19th century and reborn in quantum form in the 20th, is far more than a scientific curiosity. It is a doorway to the deepest mysteries of the universe, and perhaps of consciousness itself. According to Hameroff, these microtubules would be capable of maintaining coherent quantum states, allowing the mind to function like an orchestra of synchronized quantum collapses. This theory suggests that consciousness is not merely an emergent phenomenon of brain complexity, but the result of a direct interaction between biology and quantum physics. If microtubules can truly host quantum processes, the human mind would essentially be a conscious quantum system. 4. Evidence and challenges. Is quantum coherence in the brain possible? One of the greatest challenges for quantum theories of consciousness is coherence itself. In the macroscopic world, quantum states tend to fade rapidly due to interaction with the environment. The brain, warm and moist, would seem like an unlikely place to preserve the delicate nature of quantum coherence. However, recent experiments have shown that certain quantum processes can occur in biological systems, such as photosynthesis in plants and navigation in birds. Could the brain be an even more astonishing exception? 5. Other proposals. Consciousness as a universal quantum field. Beyond Penrose and Hameroff, other scientists have suggested that consciousness may be related to the quantum vacuum, an invisible ocean of energy that permeates all of space. According to these ideas, the mind could function as a kind of antenna, tuning into a universal quantum field and connecting all conscious beings through an unseen network. Though speculative, this vision resonates with ancient philosophical and spiritual traditions that speak of a cosmic consciousness, a universal mind underlying all reality. 6. Experiments and controversies. Can the mind influence matter? Some recent experiments have attempted to explore whether consciousness can directly affect quantum outcomes. For example, studies involving the double-slit experiment have shown that the focused attention of participants may correlate with subtle changes in the interference pattern, suggesting a possible influence of mind over matter. Although these results are controversial and require further confirmation, they open a fascinating door for future research. 7. Criticism and skepticism. Science facing the mystery. It is important to note that most of the scientific community remains skeptical of quantum theories of consciousness. Many argue that quantum processes in the brain are unlikely due to decoherence, and that experiments suggesting mental influence over matter may suffer from methodological flaws or alternative interpretations. Nevertheless, the debate remains open, and the fundamental question persists. Is the mind purely a biological phenomenon, or is consciousness a fundamental property of the universe? 8. The future of research. A bridge between science and philosophy. Quantum theories of consciousness, though still unproven, have revitalized dialogue between physics, biology, philosophy, and spirituality. They invite us to rethink the nature of the mind, explore the limits of science, and ask whether consciousness might be the missing key in the equation of the universe. In the next chapter, we will dive into the debate surrounding wave-function collapse. Is consciousness what determines the fate of quantum reality, or is everything the result of cosmic randomness? Prepare to go deeper into the mystery, where every answer opens new questions. Chapter 6. The Brain as a Quantum System. Myth or Real Possibility? 1. The bold hypothesis of the quantum brain. Imagine for a moment that your brain is not just a biological machine, but a system operating at the very edge of quantum physics. This idea, long dismissed as speculation or myth, has begun to gain ground thanks to recent experiments and scientific advances. Could it be that quantum processes, those strange phenomena that defy classical logic, are occurring within neurons, giving rise to consciousness and subjective experience? 2. Recent evidence: entangled protons and magnetic resonance. In a groundbreaking study, scientists from Trinity College and other research centers used modified MRI machines to observe the behavior of protons in the human brain. Surprisingly, they detected a phenomenon known as quantum entanglement between these protons, an instantaneous, non-local connection suggesting that the brain may behave as a quantum system. According to the researchers, this interaction cannot be explained by classical physics and points to the existence of a mediating function they identify with consciousness itself. 3. Microtubules. The quantum stage inside neurons. Microtubules, tiny tubular structures inside neurons, have been proposed as the site where these quantum processes occur. Recent studies involving anesthetics in rats showed that microtubule stability affects consciousness, reinforcing the idea that these cellular components may host coherent quantum states. Experiments using ultraviolet photons and visible light have demonstrated that microtubules can maintain quantum states for far longer than expected, long enough to influence brain function. 4. How could a quantum brain work? The hypothesis suggests that the brain uses quantum processes to perform operations beyond classical computation, enabling decision-making, learning, and adaptation in unpredictable situations. This capability could explain why the human mind can outperform supercomputers in complex and creative tasks, and why consciousness possesses qualities that cannot be reduced to conventional neural processes alone. 5. Challenges and skepticism. Decoherence and the biological environment. One of the main arguments against the quantum brain idea is decoherence, the tendency of quantum states to lose coherence rapidly in warm, wet environments like the brain. However, the experiments mentioned suggest that microtubules may protect these quantum states sufficiently to have functional impact. Even so, this hypothesis requires much more evidence and experimentation before it can be fully accepted. 6. Implications for understanding consciousness. If the brain truly is a quantum system, this would radically change our understanding of the mind. Consciousness would cease to be an inexplicable mystery and instead become an emergent phenomenon rooted in deep physical processes, linking biology with fundamental physics. This perspective could also open new pathways for treating neurological disorders and developing technologies that interact with the mind at a quantum level. 7. The future of quantum neuroscience. Researchers are beginning to explore this frontier with renewed enthusiasm. The combination of advanced brain imaging, quantum physics, and molecular biology promises to reveal secrets hidden for centuries, although much work remains. The possibility that the brain functions like a quantum computer is no longer just an abstract theory, but a hypothesis with growing experimental support. 8. Consciousness as a bridge between the physical and the intangible. Ultimately, this perspective invites us to reconsider the relationship between matter and mind. Perhaps consciousness is not a mere epiphenomenon, but the manifestation of a quantum process connecting the tangible with the intangible, body with spirit, science with philosophy. In this bridge, the human mind becomes a mystery beyond the reach of classical physics, but one that quantum physics is beginning to illuminate. Chapter 7. Consciousness, Entanglement, and Non-Locality. Are we connected beyond space and time? 1. The phenomenon that challenges separation. Imagine two particles separated by thousands of kilometers, behaving as if they were linked by an invisible thread, instantly responding to changes in one another, regardless of distance or time. This phenomenon, known as quantum entanglement, has puzzled scientists and philosophers for decades because it defies the classical intuition of a universe where everything is separate and limited by the speed of light. Could consciousness, the mystery that lives within each of us, be entangled in a similar way, connecting us through an invisible network that transcends space and time? 2. Quantum entanglement. Instantaneous connection. Entanglement occurs when two particles are generated or interact in such a way that their quantum states become linked. Changing the state of one particle results in an instantaneous change in the other, regardless of distance. Einstein famously called this spooky action at a distance, as it seemed to violate relativity. Yet experiments have repeatedly confirmed that entanglement is real, revealing a universe far stranger than we ever imagined. 3. Non-locality, breaking the barriers of space and time. Non-locality allows these instantaneous connections to exist. In a classical universe, objects are localized at specific points in space-time. Quantum physics reveals that, at a fundamental level, particles are not confined to a single location, but exist in a distributed state where spatial separation loses meaning. This opens the possibility that consciousness, if tied to quantum processes, may also be non-local, extending beyond the physical limits of the body. 4. Collective consciousness, an invisible network of minds. Some theorists suggest that quantum entanglement could be the foundation of a collective consciousness, an invisible web connecting all conscious beings. This idea, echoed in ancient spiritual and philosophical traditions, implies that our minds are not isolated, but woven into a shared fabric. If true, phenomena such as intuition, synchronicity, or deep human connection might someday find scientific explanations rooted in quantum physics. 5. Experiments and preliminary evidence. While the idea of entangled consciousness is captivating, direct scientific evidence remains limited. However, some experiments have shown surprising correlations between separated human brains, and quantum physics studies have demonstrated that entanglement can persist in biological systems. These findings open the door to future research that could transform our understanding of mind and reality. 6. Philosophical and existential implications. If consciousness is non-local and entangled, our view of self and other changes dramatically. The separation we feel between individuals may be an illusion, and the true nature of existence could be a profound underlying unity. This invites deep reflection on empathy, human connection, and the meaning of life itself. 7. Criticism and scientific challenges. As with all great mysteries, skepticism remains. Quantum physics is extremely delicate and difficult to apply to macroscopic systems like the brain. Many scientists warn against premature extrapolations that blur the line between science and spirituality without solid evidence. Still, entanglement and non-locality are real, proven phenomena, and their possible connection to consciousness remains an open and fascinating field. 8. The future of quantum consciousness research. Advances in technology and quantum theory promise new ways to explore these invisible connections. Quantum neuroscience, theoretical physics, and philosophy are converging in a dialogue that may transform our understanding of the universe and ourselves. In the next chapter, we will enter the quantum vacuum and its possible relationship with the mind. Is consciousness an emergent property of that invisible ocean, sustaining all reality? Chapter 8. The quantum vacuum and the mind. Is consciousness an emergent property of the void? 1. The invisible ocean sustaining all reality. Imagine a space that appears empty yet is filled with vibrant energy, an invisible sea permeating every corner of the universe. This is the quantum vacuum, also known as the zero-point field, a concept that has revolutionized our understanding of the cosmos. Far from being nothingness, the quantum vacuum is an ocean of infinite potential energy, a dynamic field where particles constantly appear and vanish. But what relationship does this vacuum have with consciousness, the mystery within you and me? 2. The quantum vacuum. More than empty space. Modern physics reveals that the vacuum is not a space devoid of matter or energy, but a field containing constant quantum fluctuations. These fluctuations generate virtual particles that emerge for fractions of a second, creating an energetic background that sustains the very structure of the universe. This field is also permeated by torsion waves generated by the spin of subatomic particles, waves extending throughout the cosmos, carrying information and energy at unimaginable speeds. 3. The connection between the vacuum and consciousness. Some scientists and thinkers have proposed that consciousness may be an emergent property of the quantum vacuum itself. In this view, the mind is not merely a product of the brain, but a manifestation of the interaction between matter and this invisible energetic field. Hameroff and Roger Penrose, for example, suggest that microtubules in neurons interact with the quantum vacuum, allowing consciousness to arise from coherent quantum processes within the brain. 4. Torsion waves and the invisible network of information. The quantum vacuum is not only a sea of energy, but also a field of information. Particles and material objects create vortices within this field, generating torsion waves that carry information almost instantaneously across the universe. These waves could connect every atom in our bodies with the rest of the cosmos, forming an invisible network that interlinks matter and consciousness. This idea suggests that the mind may be in constant energetic and informational exchange with the universe, a vision that opens new possibilities for understanding still unexplained phenomena, such as telepathy or distant healing. 5. The quantum vacuum as a source of energy and consciousness. Beyond its informational role, the quantum vacuum represents a potential source of unlimited energy known as zero-point energy. This energy, far exceeding the density of nuclear energy, could be the energetic foundation sustaining brain activity and, therefore, consciousness itself. The biology of the future may discover how cells and brain structures harness this energy to maintain the quantum coherence necessary for conscious experience. 6. Consciousness as creation in the in-between. From a more philosophical and biological perspective, some researchers, such as Vitiello, propose that consciousness arises in the in-between, in the constant interaction between the brain and its environment, mediated by the quantum vacuum. Consciousness would not be a static object, but a dynamic process emerging from the relationship between a system and the world around it, a continuous flow of energy and information giving rise to subjective experience. 7. Implications for science and spirituality. This view of the quantum vacuum as the matrix of consciousness unites science and spirituality, offering a bridge between modern physics and ancient traditions that speak of a universal essence connecting all things. It invites us to reconsider our relationship with the universe, not as separate entities, but as integral parts of a vast energetic and informational field. 8. The mystery continues. Although these ideas are fascinating and promising, The relationship between the quantum vacuum and consciousness remains an open field of investigation. Advances in physics, neuroscience, and philosophy bring us gradually closer to unveiling this mystery. Yet the fundamental question remains: is consciousness an emergent property of the quantum vacuum, or is there something even deeper that we have not yet understood? In the next chapter, we will explore the dialogue between philosophy and physics to ask whether science can ever resolve the mystery of consciousness, or whether this enigma belongs to a realm beyond reason. Chapter 9. Philosophy and Physics. Can science solve the mystery of consciousness? 1. The meeting of two worlds. Since ancient times, philosophy has been the guardian of the great questions about mind, existence, and reality. Physics, with its mathematical rigor and experimental method, has revealed the secrets of the cosmos, from galaxies to subatomic particles. But when both fields confront the mystery of consciousness, a fascinating tension arises. Can science, with its laws and theories, explain what philosophy has long considered unreachable? Or are we facing an enigma that transcends the limits of reason and experimentation? 2. The mind-body problem, an ancient dilemma. The relationship between mind and body has been one of the most enduring debates in the history of thought. Cartesian dualism proposed a radical separation: the mind as an immaterial substance and the body as matter. In contrast, materialism holds that all mental phenomena are reducible to physical processes. Classical physics aligned with this view, but the arrival of quantum mechanics has reopened the debate, suggesting that reality is far more complex and that consciousness may not be reducible to matter alone. 3. Science and its epistemological limits. Science is based on observation, measurement, and repetition, but consciousness is a subjective, unique, and unrepeatable experience. This private nature of the mind poses an epistemological challenge. How can science study something accessible only from within? Some philosophers argue that consciousness escapes traditional scientific methodology and that new paradigms are required to approach it. 4. Quantum physics as a bridge between mind and matter. Quantum physics has introduced revolutionary concepts that challenge classical objectivity. The role of the observer, indeterminacy, and entanglement suggest that the mind may be intertwined with physical reality in ways not yet understood. This perspective opens the door to a science of consciousness that integrates the subjective and the objective, the inner and the outer. 5. Emerging philosophies, panpsychism and neutral monism. In the search for answers, some philosophical currents have proposed bold ideas. Panpsychism holds that consciousness is a fundamental and universal property of the cosmos, present at all levels of reality. Neutral monism, on the other hand, proposes that mind and matter are two aspects of a single underlying essence. These philosophies challenge traditional views and suggest that science may expand its scope to include consciousness as a basic phenomenon. 6. The role of experience and intuition. Beyond reason and experimentation, direct experience and intuition have long been valuable sources for understanding consciousness. Spiritual and philosophical traditions have explored altered states of consciousness, deep meditation, and contemplative practices that reveal dimensions of the mind that science is only beginning to acknowledge. 7. Is consciousness an unsolvable mystery? Some thinkers maintain that consciousness may be a fundamental mystery, a primary quality that cannot be fully explained or reduced. This view does not mean abandoning inquiry, but recognizing that certain aspects of reality may lie beyond the current reach of science and philosophy. 8. The necessary dialogue. Solving the enigma of consciousness will likely require a deep and respectful dialogue between science and philosophy. integrating methods, perspectives, and forms of knowledge. Only then can we move toward a richer and more complete understanding of what it means to be conscious. Chapter 10. Existential Implications. What changes if consciousness is quantum? 1. The mind as architect of the universe. Imagine that consciousness is not a passive observer, but an active force shaping reality. If the human mind is entangled with quantum laws, then every thought and every decision could influence the very fabric of the cosmos. This idea, both exhilarating and unsettling, invites us to reconsider our role in the universe, not as mere spectators, but as co-creators of reality. 2. The illusion of separation. Quantum physics and theories of consciousness suggest that the separation between self and other, subject and object, is an illusion. If consciousness is non-local, then we are all connected through an invisible network that transcends space and time. This vision can transform our understanding of identity, empathy, and solidarity, inviting us to live with a deeper sense of unity. 3. Free will and destiny. If consciousness influences the collapse of the wave function and thus physical reality, what does this mean for free will? Are we truly free agents capable of shaping our destiny, or are we subject to probabilistic laws? Quantum mechanics opens a space for freedom within order, a balance between determinism and chance that reshapes personal and collective responsibility. 4. Death and the continuity of consciousness. The possibility that consciousness is a quantum phenomenon also raises questions about death and existence beyond the physical body. Some theorists suggest that consciousness may not vanish with death, but continue at a quantum level connected to the vacuum or a universal field. This idea challenges traditional views and opens new perspectives on life, death, and meaning. 5. Creativity and inspiration. Quantum consciousness may be the source of creativity and inspiration, phenomena that often seem to arise from nowhere. If the mind is connected to a universal field of information, then ideas and intuitions could be accesses to that vast invisible ocean, a constant flow of possibilities manifesting in human experience. 6. Ethical and spiritual responsibility. With this new vision, ethics and spirituality gain renewed depth. Recognizing that we are connected and that our actions affect not only our immediate surroundings but the quantum fabric of reality itself, invites us to act with greater awareness, compassion, and respect for life and the cosmos. 7. The dawn of a new era. We stand at the threshold of a great awakening, where science and spirituality converge to offer a deeper understanding of existence. Quantum consciousness calls us to explore not only the outer universe, but also the vast inner cosmos, where the greatest mystery of all resides: ourselves. Chapter 12. Beyond the mystery, the future of consciousness and Physics 1, the horizon of new knowledge. After this journey through the enigmas of consciousness and quantum physics, we arrive at a crucial point: the future. Science advances rapidly, and with it, our understanding of the universe and ourselves. Yet consciousness remains a profound and fascinating mystery, an unexplored frontier challenging traditional scientific categories. What lies ahead? Will we ever fully unravel the enigma of the mind? 2. Integrating disciplines, a path toward understanding. The future of consciousness lies in the integration of multiple disciplines: physics, neuroscience, philosophy, computer science, and even spirituality. Each offers a piece of the puzzle, and only by bringing them together can we construct a more complete map of the mind and its relationship with the cosmos. 3. Emerging technologies and the exploration of the mind. Future technologies, such as Quantum computing, advanced artificial intelligence, and increasingly precise brain imaging techniques will open new doors for exploring consciousness. We may study mental processes in unprecedented detail and perhaps even interact with the mind in revolutionary ways. 4. Consciousness as a gateway to new realities. If consciousness is entangled with quantum physics, it may also be the key to accessing new dimensions of reality. Altered states of consciousness, deep meditation, and profound inner experiences could be scientifically explored, expanding our existential horizon. 5. Humanity's role in the cosmos. This new understanding invites us to rethink our place in the universe. We are no longer passive observers, but active participants in the creation of reality. Consciousness, mysterious and powerful, is the force that gives meaning and direction to existence. 6. An invitation to continuous exploration. The mystery of consciousness is not a problem solved once and for all, but an endless journey, a search that accompanies us throughout life and beyond. That is why I invite you to keep exploring, questioning, and marveling at the secrets of the universe and the mind. If this journey has inspired you, if curiosity feels like the compass guiding your existence, I invite you to subscribe to the Quantum Observer. Together, we will continue unraveling the deepest mysteries, sharing knowledge, and awakening collective consciousness. 7. The closing of one cycle and the beginning of another. Thus concludes this journey through consciousness and quantum physics, a voyage that has taken us from subatomic particles to the deepest questions of existence. But every ending is also a new beginning. The human mind, with its infinite capacity for wonder and reflection, will continue exploring, discovering, and creating. Thank you for joining me on this adventure. Until next time, on the Quantum Observer.